Alright guys, I'm going to be doing a video today reviewing graphing and data tables. There's a little bit of confusion over this last week with the posters and like the stuff I asked you guys to do, so I wanted to make this video so that everyone kind of has some same baseline when it comes to graphing and data tables and like inputting and outputting values. So to start, when we have our x and y values, let me not make that a capital Y. We can refer to them as our input values and our output values. Inputs and outputs. Now, if you may have heard about plugging in numbers, this is kind of what I mean. Let's say we have the equation y is equal to negative x plus 3. In this situation, you have a y value, which is going to be our output. This y value is going to be determined by whatever our x value is going to be. So if we were to say x is equal to 1, then y would be equal to negative 1 plus 3, which would turn y equal to 2, right? Because x is 1. Now we can flip this around a little bit, and we could say, oh, if y is equal to 3, so we changed y equal to 3, and now it's asking us to solve for x, kind of change the dynamic a little bit. Now we are given some other value, and we need to solve for the other. Most of the time, we'll be solving for y, but sometimes we'll switch it around. In this case, x is going to be equal to 0. Right? So x would be equal to 0 in this case. So there's a little confusion on getting these ideas and connecting over here. Now when we talk about graphs and data points, we'll always have x as an input and y as the output. We're always going to put in some numbers for x. We'll come up with some like line of numbers, and then that'll give us outputs of y. And what will happen over here is we're just solving for different variables. So there's no really input or output. It's just, hey, we're missing something over here. We need to solve for it. Or we're missing something over here and we need to solve for it. So even though they use the same variables, they're kind of different. Now let's say we have some graph. Whenever we set up graphs, whether it's only the positive values, or positive negative values, and negative negative values, or negative positive values, we have this line, which is our x-axis, going from negative numbers to positive numbers, and we have our y-axis. Positive over here, negatives down here. If we have our equation where y is equal to negative x plus 3, we are missing two values. We don't know what x is, we don't know what y is. So we can't really put anything over here. But if we make a table where we have x and y, we can say we're going to test our x values from 0 to 5. Right, we're just saying that x can be any of these values, right? They're just existing. We're saying we're going to test these values for x. So when x is equal to 0, we will take our x that's over there and replace it with a 0. That's all we're doing. We're just replacing it with a 0. It's just taking its place now because of our table here. It's the same thing because we already did this. We get that y is equal to 3. So when x is equal to 0, we'll say that y is equal to 3 because we solved for it. Now we say x is equal to 1. All right, we still have the same equation. But now for those x's, we're going to replace that with a 1. So now y is equal to negative 1 plus 3. Y is going to be equal to 2. So there's only one thing changing. Well, technically there's two things, but we're given this line of values, possible values for our x, and we're just putting it into this equation to figure out what our y is. That's it. There's like nothing big and scary behind it. It's just you have an equation, you have a list of possible values you can put in for one of the variables, which is x, and then you're just checking each one. Same equation, it's just a new value. We have y is equal to negative 2 plus 3, so y is equal to 1. And I'll do this last one and we can start plotting points. So x is equal to 3. We put 3 where x was. So y is equal to negative 3 plus 3. So y is equal to 0. So we have our table now. It's partially filled out. We have our x-axis, which is always going to be our horizontal axis. It's always going from left to right. And then we have our y-axis. Right, this is the number line where all the y values live, going from up and down. 0 is in the middle. So when x is 0, so we're looking at this number line, we're going to go up to 3. When x is 1, so we're moving now to the right 1, and we know that y is 2, it's going to go right here, and we just keep following along down the number line. We're going to go on the x-axis first, and then we're going to see where each y value goes. And then we're going to connect the dots, and we made our line. These 4 points here. So this is kind of just a basic idea of us plotting points. We're taking values, we're not really taking values, we're coming up with just some random values over here, and we're putting those values in for x and solving for y. Stuff we should be doing, should know, but if this is refresher is needed, then here it is. I'm going to leave this up for a second, and then we're going to transition into a different type of equation, how it would look. Okay. So with our poster project, a lot of people had an equation that came up like this. We had some positive x value, some plus adding with some positive y value, and it's giving us some whole number. In this case, we have 2x plus 3y is equal to 10. Now, a lot of you were confused about how you would plot this, how you would even put it into a data table, how you could do anything with it when it came to graphing and doing the table. Let me add in some negative values real quick. So there's two things we could do. One of the things is we could change this equation to something we're used to, where we have everything on the right side and we have y on the left side. Some of you guys might know this as slope-intercept form. Let's not think of it as slope-intercept form. Let's just think about like, hey, we're going to make sure everything's away from y so that we can use that equation to solve for y. So subtract 2x from both sides. That'll give us 3y is equal to minus 2x plus 10. And then we'll divide everything by 3. And we get that y is equal to negative 2/3 times x plus 10 over 3. I'm going to change this 10 to a 9. I'm like having two fractions like that. So we get the equation y is equal to negative 2 over 3 times x plus 3. Now we can do the same exact thing we did before. We can come up with a table. We have x and y, and then we can just plug in some x values, right? We'll say that we'll start with 0, we'll go to 1, 2, 3, 4, and 5. And we're doing the same exact thing. We have a list of x values we want to test out. So we can plug those x values in for x over here, and then it'll give us corresponding y values. So x is equal to 0. Y is going to be equal to negative 2 over 3 times 0 plus 3. And then this is just going to turn into a big 0. So y is going to be equal to 3. I'll do x is equal to 1. So y is going to equal negative 2 over 3 times 1 plus 3. This is going to give us y is equal to 2 over 3 plus 3. And I'm going to convert this 3 so that we can just do some fraction math. It's going to be 2/3 plus 9 over 3. Y is going to be equal to 7 over 3, or 2 1/3. And that's all we're doing. It's the same exact thing we just did. We have a list of values we want to test out, so we can plug in those same values and start getting y values to fill out the bottom part. It's not that we're just, well, I mean, we kind of are picking just random numbers, but we already know that the numbers on both number lines exist. Those numbers are there. They're always going to be there. It's our job to see what pairing of those numbers make up our line. So I'm going to very quickly fill up the rest. Okay, so I did a little bit of math on the side. So when we plug in x is equal to 2, that gives us y is equal to negative 2 over 3 times 2 plus 3. And then that gets us y is equal to negative 4 over 3 plus 9 over 3, which gives us y is equal to 5 over 3. I've done the same thing with everything going up to 5 because that's what I have on my table. So let's see, when x is equal to 2, we get 5 over 3. That would be the same thing as 1 2/3. When x is equal to 3, we get that y is equal to 1. When x is equal to 4, we get that y is equal to 1/3. And when x is equal to 5, we get that y is equal to negative 1/3. So we're doing the same thing. We can plot some points. So when x is 0, y is going to be 3. When x is 1, y is going to be 2/3, so 2 1/3, sorry. It's going to be right over there. When x is equal to 2, y is going to be 1 2/3. A little higher. The graph's a little, and scaled a little weirdly, so fix that. When x is equal to 3, y is 1. When x is equal to 4, it's 1/3. And when x is equal to 5, y is negative 1/3. So my graph isn't scaled properly, so my line's gonna look a little weird. It's honestly like just really curved and bent. But we have plotted points and we have a line that should go through all of them if the graph is scaled properly. That's one way to do this. The thing is, whether you have it in the form of y is equal to 2 over 3 times x plus 3, or 2x plus 3y equals 9, you're going to have the same exact graph and you're going to have the same table. The only thing that's changed is the form of the equation. So, I'm gonna just make a little statement here. The equation 2x plus 3y equals 9. I'm going to use a word from our trig unit. We could say that this equation, right? It's going to be similar to this one over here. Right? The form might have changed, but they mean the same exact thing. Heck, we can even change the equation so that's in terms of solving for x. I'll do that on the side right here. We have 2x plus 3y equals 9. We'll subtract 3y from both sides. 2x is equal to negative 3y plus 9. We'll divide 2 from both sides. But that x is equal to negative 3 over 2 times y plus 9 over 2. Right, these equations are expressed in 3 possible ways, but they mean the same thing. If we were to plug in these same values over here, so like 0 and 3 into this original equation, you'd still get 9. If you plugged in 0 and 3 here, right? 0 would go here, 3 would go here, it'd still be a true statement. You did the same thing here. You plugged in 3 here and 0 here, it would be a true statement. The equation has changed forms, but they're all the same equation, just expressed in different ways. You're solving for different things. Over here, you have 2 variables that will be solved for some whole number. Over here, you have an x value and a whole number value that will be used to solve for some y value. And then over here, you have some y value and some number value here, which we'll be able to solve for x. We're just solving for different things, but they're all the same equation. This one solves for y. With x as your input. This one solves for x. Y as your input. And then this one over here, it solves for 9. With x and y as inputs. Right? They're the same equation, just in different forms. They're solving for different things. Over here, we have two inputs, x and y, to solve for some fixed number. So, it's kind of like a balancing act. Over here, we're solving for y, so we don't have to worry about putting some number in for y, because if we put a number in for x, it'll tell us what y is. The same thing happens here, but just reversed. We don't have to worry about what x is, because if we plug in some number for y, it'll tell us what x is. So it's kind of the point that we're trying to get here, that all of these equations, these equations here, they mean the same thing, they're just in different forms. Their line is going to be the same. Their table of values, it's going to be the same. It's just how you want to solve for things that changes. I'll even put another one. If we did, I'll put this in a different color so it contrasts. If we multiplied everything by 2 here, so we did 2 times 2x plus 3y equals 2 times 9. So that becomes 4x plus 6y equals 18. This equation here is the same thing as this. It's going to produce the same line. Here, we can even test it out. Let's say x is equal to 0. So that's 4 times 0 plus 6y equals 18. You can get 0 plus 6y equals 18. And then this will be 6y equals 18. Divide both sides by 6. You get the y is 3. And it matches up over here. I plugged in 0, I got 3. It's a different looking equation, but it produces the same value. Now everything's kind of jumbled up, but I hope this made some type of sense. It's a lot of information, but the basic idea is that no matter how you change an equation, whatever appearance it has, it'll still produce the same graph and table, even though they're in different forms. Okay? I hope this has been helpful. It's just going to be one video this week, since I want to really focus on this review, and I hope you have a nice day.